two theorems. The polygon angle sum theorem says that the sum of the angles of any polygon is found by taking n minus 2 times 180. Just because my back is facing you doesn't mean you get to talk. Circles have 360 degrees. They don't have any angles, so you wouldn't use n minus 2 because there's no sides. Okay, good, all right. So, polygon angle sum theorem, n minus 2 times 180. Remember, n stands for the number of sides in the polygon. Then we had the polygon exterior angle sum theorem, which says the sum of the exterior angles in any polygon is what? $360, good. No matter what type of polygon it is, the exterior angles will always add up to 360. If it's a triangle, if it's a heptagon, if it's a 1002gon, all the exterior angles, one at each vertex, are going to add up to 360. Okay? So yesterday we didn't really do anything with the exterior angles, and we did a little with the polygon angle sum theorem. Today we're going to dive deeper into those. So we should be on number 6. It's at the top of the backside. Find the sum of the measures of the angles of a 13 gon. So I want to know what all 13 angles on the inside are going to add up to. Sarah, what am I going to do? And what's 11 times 180 then? $1980?
Oh, yeah.
11 times 180?
Yeah, 1980.
Yeah, okay. I think you forgot the 1,000. You just said 980. No worries. Yeah, good. So in a 13 gon, all 13 angles are going to add up to 1,980 degrees. Part B, the sum of the measures of the angles of a given polygon is 720. How can we use the theorem that the sum of the angles equals n minus 2 times 180 to figure out the number of sides? So they're telling us that all the angles add up to 720. How can I use what I highlighted to figure out how many angles there are? Mason? Work backwards how? Good. The sum is 720. You can use your substitution rule and substitute 720 in for the word sum. And then work backwards. Go in reverse. Divide both sides by 180. You see they're being multiplied together. 72 divided by 18. So 4 equals n minus 2. Working backwards, we used to subtract 2, but now we're going to add 2 to both sides. So what's the number of sides? 6. Good. If they give you the sum, then work backwards. Divide and then add. When they give us the number of sides, we subtract and then multiply by 180. Awesome. What do we call a figure with 6 sides? Hexagon. Good. Number 7. Pentagon ABCDE has 5 congruent angles. Find the measure of each angle. So we're going to have to think about these words. Pentagon. How many sides or angles? 5. Okay, so it's got 5 angles. And then they're telling us that all 5 of them are congruent. We have to find the measure of each of the 5 angles. They are all the same because they're congruent, right? So if they're all the same, Wiggly, how can I find the measure of one of them? Divide what? Where'd you heck did you get the 540 from? That's what a pentagon is? Because you just know them, don't you? You just knew them yesterday. Good. 5 minus 2 times 180 would give me the total sum. So all 5 angles of our pentagon have to add up to 540. All 5 of them are the same. So to figure out what each is, you take 540 and divide it by 5. What's that give us? 108. So each of the 5 congruent angles is 108. What do we call polygons that have all their angles congruent? Good, equiangular. If all the angles are congruent, then it's equiangular. Equiangular polygon. You can't say it? Just keep practicing. Because there's 5 angles. So you take the total, all 5 of them equal 540, and then you divide by 5, because 5 angles have to add up to 540, and they're all the same. What do you mean that both are 5? No, it's a pentagon. So you take 5 minus 2 times 180 to figure out what they all add up to. And then to find the measure of each of them, you divide it by, because there's 5 of them. Yeah. Yep. We're going to skip number 8 and do 9. Number 9 says to find the measure of angle x in quadrilateral x, y, z, w. The directions really aren't that good because, well, I don't have x, y, z, w. And the angle I want you to find isn't even inside of the quad. It's this one on the outside. So just find x is really all I want you to do. Interior or exterior angle? Exterior angle. So can I add 95 and 60 and say that's x? What about 60 and 100? So I should just add all 3 of the interior ones to get my exterior angle. But why can't I do that? We did that with triangles. But these aren't triangles. Good. That exterior angle theorem that we did the last 2 days where the exterior angle of a triangle equals the sum of the interior ones, that's only for triangles. So what am I supposed to do then? Add all 3 of these ones together. So 160, because that's that, plus 95, 255. So that's what x is? Oh. Y from 360? Oh, because all the ones on the inside add up to 360? Right? Because it's a quad. So the outside one's 105? Good. My last interior angle would be 105. 360, because it's a quad. Hopefully you guys know that one. Then 105 and x form a straight line. So using our angle addition postulate, 1080 minus 105 would give us 75. Awesome. Once you have that one written down, go ahead and go down and do number 10. If the figure is a polygon, name it by its vertices. Give it a first and last name. Remember the first name based on the number of sides. Then his last name comes from the vertices. If it's not a polygon, explain why not. The first one on 10, based on the number of sides, what would you call it? Quadrilateral, right? 1, 2, 3, 4. And then using the last name, you use the vertices, so you could call it ABCD. So we'd say that's quad ABCD. That's classifying it. Naming it is using sides and vertices. If I were to classify it, I would say that it's concave. Your second one, polygon? Why not? Good. No, we'll say segments intersect at more than their endpoints. Between endpoints. Make sure you write in between endpoints there. The segments can only intersect at endpoints. Cool. Number 11. A pentagon has two right angles, a 100-degree angle, and a 120-degree angle. What is the measure of its fifth angle? I'll give you a minute. See what you can come up with. How many angles does a pentagon have? 5. It's got 5 angles. Good. And those 5 angles are supposed to add up to what? 540. Yep. 5 minus 2 times 180 gives me 540. We know 4. 2 of them are right angles. What's a right angle? If I have 2 of them, how much is that? 180. One of them is a 100-degree angle. And the fourth one is 120. If I add these up, 0, 10, 1, 2, 3, 4, I get 400. So the 4 add up to 400. How are we going to figure out that fifth angle measure then? Yeah, subtract 400 from 540. And we get 140. All 5 have to equal 540. We found the sum of 4 of them to be 400, so subtract that and you'll get your fifth angle measure. Make sense, Ben? Okay. The last one. ABCDEFGHIJ is a regular decagon. Find the measure of angle ABC. You have 2 words. Regular, decagon. What does decagon mean? It's a 10-sided figure. Good. How about... Good. Regular means that all sides and angles are congruent. Okay, so I have a 10-sided figure, which means there's 10 angles. And since it's regular, all 10 sides and all 10 angles are congruent. I want to find the measure of one of those angles. When it says the measure of angle ABC, that's one angle. What do you think, Jack? How'd you get that? And that gave me 1440. And what does the 1440 represent? Yeah, all 10 of them, right? But if they're regular, all 10 are the same. And if I want the measure of one of them, I got to divide 1440 by what? 10. Good. So the measure of angle ABC then is 144 degrees. All 10 angles have to add up to 1440. It's regular, which you told us means the angles are congruent. So all 10 angles are the same measure. If all 10 angles equal 1440, figure out the measure of one of them, you just divide. You think, how many 10, what's a degree measure times 10? That's going to get me 1440, so you divide. Because I had to find the total. Always, yep. All right, based off the same information, it says that angle XBC is an exterior angle at vertex B. And they want us to find that. Here's 3 of my 10 sides on my decagon. I'm just going to do those 3 sides. We just figured out that angle ABC is 144. Angle XBC is an exterior angle. That means it's on the outside. So it's got to be formed by one side and the extension of another. So here's angle XBC. This is the one they want me to find. Why would I take 180 minus 144? Yeah, because my interior angle and my exterior angle form a straight line, which means they have to add up to 180. 180 minus 144, what do we get? 36. So my exterior angle is 36. So if you look at my picture, an interior angle and an exterior angle are adjacent and always what? Adjacent means next to. What else do you notice about them? They always are supplementary. They make a line. An interior and an exterior angle have to make a line. So they have to add up to 180. At the beginning of the notes, we reviewed yesterday's theorems, that the sum of the interior angles has to add up, or excuse me, the sum of the interior angles is found by using n minus 2 times 180. What did we say about the sum of the exterior angles? What's the sum of the exterior angles? 360. What kind of polygon are we dealing with? Regular, which means what? All sides and angles are the same. That means the exterior angles too. How many exterior angles are on this polygon? 10. It's a decagon, right? So Franson says that all the exterior angles have to add up to 360. Colleen says there's 10 of them. And they're congruent because it's regular. If all 10 angles have to add up to 360, how are we going to figure out what the exterior angle measure is? Divide it. So you wouldn't have had to draw a picture. You know that the exterior angles have to equal 360. And if it's regular, they're congruent. So there's 10 of them. What's 360 divided by 10? 36. Two ways to do this. You can draw a picture and understand that the interior and the exterior angle will always be supplementary. Or you can think, my exterior angles have to add up to 360. There's 10 congruent ones. So each of them must be 36 so that they get to 360. Take your note packet and flip it back a page to that table we filled out yesterday. Below that table, you have 4 sentences before we got to number 3. It says the sum of the interior angle measure. How do we find the sum of the interior angles of any polygon? N minus 2 times 180. If it asks what's the sum of the measures, you're going to use n minus 2 times 180. The second sentence, cross off that sum. How would we find the measure of each interior angle of a regular polygon? You have to think about what regular means. Good, exactly. N minus 2 times 180. That gives me what all the angles would add up to. But since it's regular, they're all the same. So to find the measure of one of them, you divide however many there are. Third sentence. The sum of all the exterior angles. 360. The sum of the exterior angles for any polygon is always 360. In the last one, it's not the sum. I just want the measure of each exterior angle of a regular polygon. How would I find one exterior angle of a regular polygon? Good, 360, what they're all supposed to add up to, divided by n, the number of angles, or the number of sides. They're regular, so they're all the same. You have to know the sum of the interior and the sum of the exterior. You guys are smart. You should be able to figure this out without having to know these formulas. If you know that all the angles have to add up to 540, and all 5 of them are the same, then you should be able to realize that you just divide by 5 to get one angle measure. Or if all the exteriors have to equal 360, and all 10 of them are the same, then you should just be able to divide by 10. But there's that for you to refer to. So when you're doing your homework, you don't know what the sentence is asking, come here and see if it matches one of those. Capiche? All right.